All right, folks, today we're going to take a look at the Bazinga case study. That's project number 2. Basically, this is just a normal distribution problem, right? So you're looking at deciding how many t-shirts we're going to make, right? At the end of the day, we're all over the place with this. We have all these managers who don't really know what they're doing. However, we need to make sure that we know what we're doing so we can push forward and do a good job here. So the CEO has decided that he wants to put you in charge of his management team. So each of the managers has recommended a different quantity be ordered. Here we have Amy, Bernadette, Howard all the way down. And as you can see, they're all over the place. So what we want to do is use this information as a starting point to decide exactly where it is that they want to produce their t-shirts. Before we get into that, however, let's pull out some information here, right? The first thing is that Leslie Winkle has no idea how many t-shirts she wants to make. All she knows is she wants to avoid extremes. That part there about avoiding extremes is important, right? You don't want to be left holding excess merchandise that will leave money on the table and cost you money down the road. You don't want to have lost sales because you didn't produce enough. So you don't want to have too many or not enough. That's what she means by avoiding extremes, right? In addition to that, she knows that we can use the previous sales as a starting point. The previous sales are going to be our starting point, right? So we're going to go from there. We also know that if we can sell them at retail, right, we can sell them for $25 each. If not, we can sell them for $10 each, and the shirts cost us $15 to make. So every shirt that we sell at retail, we're going to make $15 off of, $10 off of, 25 minus 15. Every one that we sell at wholesale, we're going to make minus $5 on. However, that's still preferable to holding on to the shirts because then we would lose $15. All right. With that in mind, let's get started. Now, we're going to use the manager's predictions to figure out what the expected value and standard deviation would be. The expected value is also known as the mean, right, or average. So we're going to try to use that to find out the mean or average of these numbers. Let's go over and take a look at that and make sure we get that done. All you have to do is hover over the table of the figures here, and in the upper left-hand corner, when the radial dial pulls up, you click that, and then you can copy and paste. Alternatively, you can simply copy, Control C for copy, and we'll come over to Excel spreadsheet and paste. Now, for this particular problem, you're going to need the data analysis tool pack. For a Mac, it's a simple matter of going to File, Options, Add-ins. Manage the Excel add-ins and click Go. And you'll check all of those boxes and click OK. For a Mac, the tool pack is in the toolbar at the top, so you'll have to pull that down and do it from there. All right? So I'm going to erase these instructions here. And now you see we have our manager's names with the suggestion. We're going to use that as a starting point to decide what our mean and standard deviation will be. How do we do that? We go to Data, Data Analysis, Descriptive Statistics. Click OK. The input range is going to be the suggestion and the numbers. That'll be C2 through C8. Check the box that says labels in the first row. My output range is going to be F1. Check the box that says summary stats and click OK. Now you'll see that I'm given my mean and I'm given my standard deviation. Those numbers will be important, so I'm going to go ahead and highlight them so I know where they are later. The rest of this is not important, but let me just go through it real quick, right? We look at all of these numbers and we see our skewness is 0. That means this is going to be a nice normal distribution when we're done. The standard error, the median, and all of that's not as important, but what we do know is when the mean and the median are the same, our data are not skewed. Again, let me say when the mean and the median are the same, our data are not skewed. Okay? So, with that in mind, let's now use that to complete problem number 2. It tells us we're going to use the standard deviation, whatever, to calculate the actual sales. So we've done that part. That is done. Check it off the box. We're now going to use that expected value and standard deviation to develop a normal distribution graph that we can use to analyze the data. We go back over here to our data, and we see here are our numbers. Here's the mean, the standard deviation, and so on and so forth. What I'm going to do here is I'm going to start at roughly, say, 0, and we'll go up from there. When we see our mean, we see it's 375. We want that number to be roughly doubled, so that's going to be 750,000, right? So that means that our graph is going to go from 0 to 750,000. And we're going to count them up by 50,000 units at a time. So we're going to go 0, 50, 75, 100, so on and so forth. Once you have 3 of them in place, you can highlight those 3, left click and hold a little green dot, that's called the fill handle, and then you can simply drag it down until you see the numbers count up to 750,000, or 700,000 in this case, 750 here. This is where we want to stop at 750,000. Again, that puts our 375,000 roughly right in the middle here. Okay? Now, if you want it to be tighter, if you want it to be closer together, you can say 0, 25,000, so on and so forth, but this is sufficient for our purposes. Then we're going to use 2 different formulas. One's called a PDF, that stands for probability density function, and a CDF, cumulative density function. This is the probability of exactly one number, exactly 0, exactly 50,000, so on and so forth. This is the probability of up to and including that number. To get the PDF, we're going to say equals norm.dist, normal distribution. We're going to pick our x, put in a comma. We're going to pick the mean and make it an absolute reference by pressing either F4 or Command T on a Mac. Then we're going to do the standard deviation. Again, we're going to make it an absolute reference. And we want to make that false because it's a probability density function. So here's your formula. Norm.dist, pick the number just to the left, G3, G7, false. Now the G3 and G7, again, are the mean and standard deviations. We press enter and we see that that is a relatively low number. Actually, it's 0. If you rounded that off, it'd be 0. Okay? Then we autofill all the way down and we have our probability density function. You'll notice that the probability of 0 and the probability of 750,000 are exactly the same. Okay? In our CDF, it's going to be exactly the same formula. It's equals norm.dist, pick the x, pick the mean, lock it in, pick the standard deviation, lock it in, make it an absolute reference. Again, that was F4 on a PC or Command T on a Mac. And this time we're going to make it true. True means it's a cumulative function. All right, and so then we autofill from there. You'll notice that it goes from 0 to 1. If we round these numbers off to the nearest whole number, we get 0 to 1. I'm going to make it 4 decimal places just to make it a little bit easier to read. At this point, I encourage you to go ahead and save your document. So we do Control S and save. And I'm going to highlight all of this data, insert, line chart. And you'll notice that I basically have 2 graphs here. I have the blue line across the bottom, and I have the orange curved line across the top, right? Well, I need both of those to show up. This blue line is actually supposed to be a normal distribution. I'll show you how to do that. We're going to click that orange line, then we're going to right-click it, format the data series, plot it on a secondary axis. And now you have this nice normal curve along with the probability density function in the blue and the cumulative density function in orange. This gives you the graph that you need to be able to look and analyze your data. One last thing we need to do, our numbers only go from 0 to 1. So we're going to reformat that axis by right-clicking any of these numbers, format the axis, and then we're going to make the maximum 1.0. Press enter. So now you have the graph that you need in order to be able to complete the project. We'll go ahead and change the chart title here. We'll just call this normal distribution. And we're done with our chart. All right, we'll take this guy right here. We'll copy that. We'll put him over here somewhere into our Word function so that we can find it for later. All right, so now let's go back to the Word document. Scratch that one off the list. We're done. Okay. All right. And the third thing says we use the swag method. The CEO believes that the best case scenario is 560,000, most likely 390. Worst case is 228. If you don't know what the swag method is, I encourage you to Google that and figure out what's up. Okay? You need to know that term. It's very, very important. All right. So the best case scenario is 560, most likely is 390, worst case is 228. Okay, we're going to pull that to the side, get him out of the way, and I'm going to move my chart down as well, get that out of the way. Now what I need is to put all of that data into some sort of nice table right here. So we're going to take best case scenario, most likely, and worst case, and we'll just label them, right? We'll put best, most likely, worst. Okay, and the CEO here said 560. For that, 390 and 228 here. Now, as a note, if the data don't necessarily come out the way you think they should, it's probably because, again, we're using the swag method. That doesn't necessarily mean that we're incorrect. It simply means that we're giving it our best guess. And we need to decide at that point whether or not it's worth it to us or whether or not we're going to have some other way of developing the data. Okay? Now, what we need to do now is develop the probability of a stock out for each of the three cases along with the profit projections associated with each one. So let me define a stock out for you. A stock out is when we run out, when we don't have enough to meet demand. In other words, what is the probability that if the best case scenario happens, we're going to run out? What's the probability that if the most likely happens, we're going to run out of t-shirts? Worst case scenario, we're going to run out of t-shirts. How do we do that? Well, again, we're going to rely on the mean and standard deviation to do a normal distribution. So what we're asking is if the best case scenario happens, what's the probability that we're going to run out of t-shirts, right? Or what's the probability that we'll sell at least 560,000, at least 390, at least 228? When you hear the words at least, what it really means is that you're going to have greater than. So we're going to say it's the probability of X greater than whatever that number is. And I'll just put in a question mark here so that I indicate it's the probability of X greater than 560, 390, so on and so forth. Now, when it's greater than, we're going to have to subtract our distribution or our probability from 1. So we're going to say 1 minus norm.dist, pick the X, pick the standard the mean rather. Again, we're going to make that an absolute reference. Pick the standard deviation, make that an absolute reference, and make it true. Okay. So my formula again is 1 minus norm.dist, open parentheses, pick the 560,000, comma, pick the mean and press F4 or Command T to make it an absolute reference. Pick the standard deviation and again press F4 or Command T, make it true. And the answer you should get is 0. Why? Because there's very little chance that we're going to sell more than 560,000 shirts when the mean is 375,000. I'm going to increase that decimal place, however, so that I can see we actually have a little bit of a chance. If you want, you can go ahead and change that to a percentage and increase the decimal so we see we have a 2.4% chance of selling more than 560,000 shirts. We're going to left click the fill handle and drag it to the right, and we'll see that our probabilities associated with each one are 2.4, 43.6, and 94.2%. Again, this means there's a 94.2% chance that we're going to sell at least 228, 43.6% chance of at least 390, and only a 2.4% chance of at least 560,000. So that then satisfies this part, right? We're here now, developing the probability distributions. Now let's look at how much profit we will make if we actually sell these shirts. If you recall, we said that we would make $25 off each one, and it cost us $15. So let's go ahead and put that information in here, right? So our revenue number is going to be $25, and our cost number is going to be $15. So our contribution margin is going to be equal to 25 minus 15. Yes, I know you could have figured that out in your head, but we're going to use that for something else later. So we're going to make $10 off of each one, right? $10 off each one. And that's not a bad contribution margin for t-shirts. So if we make $10 off each one, all we have to do is figure out what the profit would be if we sell each of these amounts. That's a simple matter, right? So we're going to look at our profit at each of those price points, and we're simply going to say equals the 560 times the $10. Make the $10 an absolute reference, again, by pressing F4 or Command T. So we're going to make 5.6 million here, 3.9 million here, and 2.28 million here. I change those to dollars. Of course, I'm going to round off the zeros because when you're talking about 5.6 million, pennies don't matter. So my profit projections under the best case, most likely, and worst case scenarios will be 5.6, 3.9, and 2.28 million dollars. All right. Okay. Now, we are now on to number 4. Number 4 tells us we want to use the worst case, most likely, and best case scenarios for the profit projections of each of the manager's suggestions. Now, this one's going to get a little complicated. So here's where you need to put down the cell phones, stop playing with the cat, and pay attention. All right? What do we mean by all of that? Well, we have all of these best case, most likely, and worst case scenarios. We want to know what the profits will be if we follow those manager's suggestions. So, if we do what Amy says, and we could have sold 560,000, how much money will we make? That's what we want to know. All right? So the way I'm going to do that is simply take these numbers here. I'm going to copy them. I'm going to paste them here. And then I'm going to take the profits, I'm going to take the suggestions, I'm going to paste them here. So I'm going to take Amy, Bernadette, Howard, Leonard, Penny, and Raj, and I'm going to paste them right here. So now, I could have sold 560,000, but I only made 500,000 shirts. I did what Amy said. In the best case scenario, I'm going to be able to sell all that I make. So to figure out what the profit projections would be here, all I have to do is multiply how many we made by what our contribution margin is, right? So we manufactured 500,000 shirts. We multiplied that by $10 contribution margin, make the $10 an absolute reference, and then we autofill from there. So under the best case scenario, if we do what Amy says, we'll make $5 million. All the way down to if we do what Raj says, we'll only make $2.5 million. Now let's take a look at the most likely scenario, $390,000. Here, Amy told us to make 500,000 shirts. We are only able to sell 390,000 of those shirts. So that means then we're going to have some left over. As a matter of fact, we're going to have 500,000 minus 390, which is 110,000 shirts left over that we have to sell not at $25, but we're going to have to sell them at minus $5. We're going to lose $5 off of each shirt. But again, losing $5 is still better than losing the 15 if we didn't sell them at all. So how do we account for that? We're going to say equals, open parentheses, 390 that we could have sold at the right cost, right? Make it an absolute reference, times the $10 we could make that an absolute reference, plus the difference between 500 minus the 390, press F4 to make it an absolute reference, times minus 5. All right, excuse me, I should have put that outside the parentheses, times minus 5. So let me go through that formula and explain what we did here. Here, in the first half, we're looking at the entire $390,000 that we could have sold, times the $10 that we made off them. This is our good profit. Over here, behind that, we have to take into account the fact that we're going to have to sell 110,000 shirts at wholesale. So that's the difference between 500,000 and 390 minus the times the minus $5. If you did it right, you're going to make $3,350,000. Now this holds for Amy, Bernadette, and Howard. Here we could have sold more shirts. We did not sell all that we made under those suggestions, right? So in other words, we have some shirts we're going to take at a loss. When we get to Leonard, Penny, and Raj, however, Leonard only said make 350. We could have sold 390, so in this case we can sell all that we make. So we're simply going to take the 350 times the $10 that we make up here, and that's the only part of that equation we have to worry about. Okay? All right. And we'll make these dollar signs as well, give them the same format. All right? So, as a matter of fact, I'm going to go ahead and take all of this now and make it all the same format so we have the same numbers here. Now, in this last column, Amy said make 500,000. We could only sell 228. We're going to have to sell a significant amount at a loss. As a matter of fact, every one of them are going to have shirts they sell at a loss. So we're going to have to account for that, and we're going to say equals the 228, make that an absolute reference, times $10, make that an absolute reference, plus, excuse me, hit the wrong keys there, all right, plus the difference between the 500,000 minus 228, make that one an absolute reference, close parentheses, times minus $5. All right, and you should get 920,000 here. Again, that's 228 times 10 plus the difference between 500,000 minus 228 times negative $5. We autofill from there. All right. Now, putting all of that together gives us this nice table that we can take a look at and see what our profitability margins will be. So this again is the best case, most likely, and worst case scenarios. I'm going to copy that. I'm going to paste it here so that I see that in my graph. All right. Last thing I want to do here is I'm going to add this thing called the expected value approach. And all that's going to do is give me the expected value of each of these. So I'm going to take the profitability times the probability to get that number. Okay? The way I do that is the sum product, and I take my profitability numbers, comma, my probability numbers, and when I do the probability, I'm going to make those an absolute reference. And then close parentheses. So that sum product of the profits times the payout, or the probability. and then I autofill from there, and I make that rounded to the nearest dollar. Now, when I put all of that together, it looks like Raj is doing pretty good here, right? It looks like Raj is going to win under the expected value approach because we're not expecting to sell a whole lot of these t-shirts. But there's a little flaw in the logic here, in that 94.2% is not necessarily the number that we're going to sell. We know we're going to sell at least that many. In other words, we're going to sell greater than or equal to 228,000. So when you do your analysis and give me the recommendation, you're going to have to take that into account. In the meantime, what you can do is take all of these numbers here, insert them into a nice column chart like this one, and click OK. Now, if you change that to chart style number 2, it will give you this nice graph with all of the projections on there, so on and so forth. The only thing it didn't do was give me series 1, series 2, so let me fix that, right? That's because I forgot to highlight this, all right? So we're going to highlight here, we're going to highlight the best, most likely, etc. by holding down the Control key, and we're going to insert a recommended chart again. Excel's not wanting to play well with others. So here's my workaround. I'm going to highlight the best, most likely, and worst case scenarios along with the expected value. Copy that, paste it here. Then I'm going to take each of the managers' names and their suggestions and their payouts, Control C for copy, and I'm going to paste it here, but I'm going to right click and paste just the values. Right click and paste just the values. Okay. Now I have Amy, Bernadette, and so on and so forth, so I need to take these numbers now and I'm going to make them again into dollar signs. Okay. Now when I highlight the names and I highlight here, I insert recommended chart, insert column chart, I get my numbers. Okay, again, Excel is not wanting to play nice with others. Oh, I see the problem. You need to have Amy, Bernadette, Howard, Leonard, Penny, and Raj right next to the stuff. So I'm going to take this guy right here. I'm going to delete this out by right-clicking, delete, shift cells to the right. Okay. So we're going to right-click, delete, shift cells to the left. All right, and do the same thing here. Delete, shift to the left. So we've got everything lined up now. Okay. All right. So now let me go ahead and do this. All right. There we go. That's the chart I'm looking for. So now I'm going to click chart style number 2. Okay. I'm going to change the title to profit projections. And when I look, I see under the best case scenario, Amy wins. If the most likely scenario happens, looks like Howard wins. Under the worst case scenario, it looks like Raj wins. And under the expected value approach, they're pretty much even, with maybe Leonard coming out with a slight advantage here, right? So maybe Raj, you guys just take a look at that and you can analyze that for yourselves. Okay. Now we're going to copy this. We're going to come over here again to our Word document, right? And we'll paste that in. Make sure that you have all of those graphs and charts in there. Okay. All right. So again, we have all of our profit projections with each of the manager's projections. All right. Now, so that leaves us here. We're done with number 4. That leaves us here with number 5. The CIO has decided that the potential of this product is so great that he would like to make sure that you have only a 25% chance of a stock out, 75% chance of meeting demand. Right? So we're going to take that, I'm going to copy that, and I just need to make sure that I have my numbers right. So I'm going to come down here and I'm going to paste it in somewhere like this. Right? 25% chance of stock out, 75% chance of meeting demand. What does that mean for me? Well, that means that I want to make sure that I have at least that much merchandise so that I have, no matter what our sales are, I have a 75% chance of meeting the demand. So here we're given the probability and asked to find the x. And when that happens, we use another formula called the norm inverse formula. So to find this, we're going to say equals norm dot inverse. The probability we want to match is 0.75 or 75%. The mean, again, is up at the top here at 375. Okay. The standard deviation is going to be here. Let me double click again. Let's start that over, right? So it's equals norm dot inverse. Pick the 0.75. Find our mean, okay, which we know to be 375. Find our standard deviation, close parentheses. So again, that formula is norm dot inverse, 0.75. Then we picked our mean and our standard deviation. And that tells me that if we make 438,000 shirts, that we will have a 75% chance of meeting demand. Okay? All right, now let's look at the last one here. She needs to know how many t-shirts to make. So it's up to you to make that decision. I'm not going to show you how to do that one because I've shown you all the other stuff on how to do the math. What I'm asking you to do here is come up with a number. Don't hedge your bets and don't say something like, well, it needs to be between 10,000 and 100,000 shirts. No, tell me exactly how many to make and tell me why. Think about all of the things we've looked at, right? We looked at our profit projections. We looked at our normal distribution graph. We looked at the best case, most likely, worst case scenarios. We figured out what our profits would be if we followed the swag method. We did all of this stuff. So you need to analyze and synthesize all of that material together in such a way that you can come up with a solid, cogent answer as to how many shirts should we make. All right. Now, you'll put that together in a managerial report with a cover sheet, a one-page executive summary of your findings, put the charts and graphs into an appendix, and away you go. I hope you enjoyed and have a nice day. If you have any questions, don't hesitate to contact me.